Okay, this 11.5, which is going to be about equations of lines in 3-space and equations of planes in 3-space. So in the plane, slope is used to determine the equation of a line. So when you have an x and y, so in 2 dimensions. In 3-space, the equation of the line through, say, point P0 equal x0, y0, z0, and point P1, so point 2 equal x1, y1, z1 is given by RT equal to P0 plus P1 minus P0t. The P1 minus P0 is a vector, which we call v, so it's the direction of the line. So let's make some observations. So in particular, when you put 0 for t, we get P0. So let's note that. So when t is 0, you can think of t as like time. So at time 0, you put 0 in here, you'll be left with P0. And when time is 1, so when t is 1, put a 1 in place of t here, P0 plus P1 minus P0. The P0 and minus P0 will cross off and you'd be at P1. So you can see that this guy here passes through both P0 and P1. So this is the equation of the line. Okay, let's look at an example now. Okay, so here's an example. It says find the equation of the line with given characteristics. So we've got part A and part B here. Part A says passing through the point 5, minus 2, 1. And this symbol here means parallel. And so parallel to this vector. That's part A. And part B is actually from the practice quiz is number 3. And says passing through 2, 7, 1 and 1, minus 2, 0. So find that line and then determine if this point lies on the line. Okay, so let's do A first here. So I'm going to erase some things. Okay, so let's do A. I'm going to erase up here. Okay, so let's look at part A. So it's passing through 5, minus 2, 1, parallel to this vector here. So here's our equation of the line here that we'll be using. So the 5 minus 2, 1 is the P0, and the V, our vector, is basically our P1 minus P0. So we don't know what P1 is, but it doesn't matter. The V is kind of like the slope, if you want, of the line. It's pretty much it's the analog of the slope in 2 dimensions. Okay, so let's replace our things here. So we get this then. Okay, so this t can multiply into each of those. So writing it out then, so there's going to be 5 here, then plus 2t in the x component. It'll be minus 2 plus 0t and 1 minus t. So let me write that here. So we get this. So again, it's 5 plus 2t. That's how I got that. Then minus 2, 0t here, 1 minus t here. Then we can write that using the ijk notations. Let me do that. So we get then this guy here. So that would be the equation of the line through 5 minus 2, 1 and parallel to this vector. Just to check at time 0, we put 0 in for t here. It'd be 5 minus 2, 1. So you'd be at your start point. Okay, so we're done with A. Let's now do part B. So I'm going to erase this now. So part B. Okay, so let's do part B. This is also from the practice quizzes number 3. So to find the line passing through 2, 7, 1, 1 minus 2, 0, and then determine if 0 minus 2, 1 lies on the line. So I'm going to call this first guy, say P0, and this one P1. Doesn't matter which one you call P0 and P1, but I'm going to call this first one P0 and this guy P1. Okay, so I've labeled them P0 and P1. Now let's write our equation of the line here. So here's the equation of the line. Alright, so here's the equation of the line, and let's make our substitutions for P0 and P1 now. Let me write it here. So making those substitutions, so again P0 is 271, and P1, 1, 2, 0 minus P0. So simplifying this, let's do that. we get this then. So I went 1, minus 2, so minus 1, then minus 2, minus 7, so minus 9, and 0, minus 1 here. And then it's going to be then 2 minus t, 7, minus 9t, 1, minus t. Let me write it here. So we get this, will be 2 minus t, 7 minus 9t, 1 minus t. I'm not going to use the ijk notation here, I'm just going to leave it like this. So now we need to decide whether this is on this line. So in particular, if it is on the line, we should be able to find a t-value here that makes that point. Okay, so let's assume it's on the line and see if we can make it work. So supposing that we can find a t-value that makes this point, that would mean that the 2 minus t needs to equal 0. The 7 minus 9t needs to equal minus 2. That's what I have here. And the 1 minus t needs to equal minus 1. That's what I have here. So these three equations need to be true at the same. So the same t-value should work for all three. So solving the first one, so adding t to both sides, looks like t is going to be 2 for this one. So we have t is 2. And then the second one, so I can subtract 7 on both sides, and I got minus 9t equals minus 9, right that here. So I get that, then dividing both sides by minus 9, we'll have then t is 1. Well, that's a problem now because we have t is 2 here and t is 1 here. So that means actually that this is not on the line, because for it to be on the line, the t-value should be the same for all three. Okay, so let me just note that here. So again, since the t equals 2 and t equals 1 aren't the same, not the same, so hence we can say that our 0 minus 2 negative 1 is not on the line. Okay, so we're done with the question then. Okay, I'm going to stop the video here, and we'll continue in the next video. And in the next video, we'll talk about finding equations of planes. Okay, so let's leave it there.